Let's look at another situation involving radicals where we might want to try to simplify by squaring both sides. One thing I could do right off the bat is just square both sides as is. Square the left and square the right. And that would give me a root 6x minus 2 times a root 6x minus 2. And those two roots would, in fact, cancel out, and we'll just get a 6x minus 2 there. But think about it. What happens if we do that? The right-hand side is fine. And when I take the two first terms, the root 6x minus 2 times root 6x minus 2, that's going to be fine. But I'm also going to have this 3 times root 6x minus 2 and another 3 times root 6x minus 2. So that's going to give me 6 times root 6x minus 2, and I haven't gotten rid of the radical at all. So we don't want to do that. If we're going to want to square both sides, we're going to want to do so in situations where we have something more like the radical of some expression directly equal to another expression. Could say expression 1 and expression 2. Well, how can I get that? How can I get the radical of an expression equal to another expression? Well, here it's particularly easy. All I have to do is subtract 3. So now I have the radical of 6x minus 2 equals x minus 3. And now if I square both sides, I get rid of the radical completely. There's no radical on either side. I do get this x minus 3 squared on the right. But I can deal with that. We know that x minus 3 squared is x squared minus 3x twice plus 9, because minus 3 squared is 9. And I can move everything over to one side. I will get, let's see, minus 6x minus 6x. So that's minus 12x. And then plus 9 plus 2 plus 11. So we want to find the solutions to this. You might be a little intimidated because 11's a larger number than some of the numbers when we factor, but 11's prime, so we don't have a lot of choices. So if this has a solution in the whole numbers, it's going to be easy for me to find, for us to find, that is. Well, I'm going to need to factor 11 as 1 times 11. I also want plus or minus 1 plus or minus 11 to equal negative 12. Well, I need to have a plus here, so these can both be negative, and if I take negative x, negative 11x, and combine them, I get negative 12x. So, a product here is equal to 0, if and only if one of the two pieces is 0. And at this point, I want to stop, and I want to ask myself whether or not both of these make sense. So, let's go back to our original situation. What happens if we plug in 1? Well, if we plug in 1, I'm going to get the square root of 4, because 6 minus 2 is 4. So I'm going to get 2 plus 3 equals 1. Is it true that 2 plus 3 equals 1? No. So I'm going to get rid of this. What about 11? What happens if I try plugging in 11? Well, let's try maybe doing that by writing it out. I'd get 66 minus 2, because 6 times 11 is 66. Not too hard to multiply a single digit number by 11. So, what is this? Root 64 plus 3 equals 11. So is it true that 8 plus 3 equals 11? Sure it is. So because of that, I know this x equals 11 is an actual solution. And since these were the only two possibilities, we've now found all solutions to this original equation. So we're done here. But just really briefly, if you're asking yourself, why did this even show up? Because the idea of 2 plus 3 equaling 1 is kind of strange. It's a little less strange if you look at this line. This is actually the thing we squared. And if we were to try to plug in 1 here, what would happen here? Plugging in 1, I get 6 minus 2, which is 4, equals minus 2. So root 4 is what I have here, and minus 2. So I have 2 and minus 2. Okay, 2 is not equal to minus 2. The answer is still ridiculous. However, remember what we did. We squared both sides. And we were looking for solutions to the left-hand side squared equals the right-hand side squared. Is it true that negative 2 squared equals 2 squared? Yes. So actually, this is a solution to the equation left-hand side squared equals right-hand side squared. It's just not a solution to left-hand side equals right-hand side. And it's not a solution to our original equation. So, what have we learned here? Well, hopefully we've learned that if you have a root and you want to get rid of it by squaring both sides of an equation, you probably want to isolate that root first. Put the root by itself on one side, and then you can square both sides. And we've also seen another example where squaring both sides gave us some solutions, which weren't actual solutions to our problem. And we talked a little bit about why that incorrect solution showed up. Still incorrect. This is our only answer. But hopefully we saw a little bit about what's going on that's creating these fake answers. Let's do some more examples with radicals because there's a few other things which can come up.